Ready now. Good afternoon, everybody. Welcome to Dispatches from the Energy Transition. We're already pretty into January and the new year. We have a great episode today, episode 8. So we've made it to our second year, and we're going to talk about installing solar on challenging landscapes. There's a couple landscapes going on right now, and we'll talk about them today. Dispatches is brought to you by Mayfield Renewables and Outfit. I'm the principal of Outfit. We are a clean tech marketing agency wholly focused on distributed generation. And per usual, I'm here with my partner for Dispatches, Lucas Miller, senior engineering consultant with Mayfield Renewables. How are you, Lucas?
Doing well. Feels like 2025 is already in full swing.
Yeah, we have a great episode today, right? With a couple of industry veterans and a unusual project, pretty involved project.
Yeah, we're excited to talk about this one. This was a project that Mayfield worked on in tandem with Kokosing and OMCO. For those of you who don't know, Mayfield is an engineering consultancy. So we do system design engineering, feasibility studies, preliminary analysis, as well as education and training, mostly focused on mid-market solar and energy storage projects and products. And today, we're joined by a couple of guests on one project that we worked on going back in the last year or two in southwestern Ohio. So we want to welcome our two guests here today. I'll let you guys both introduce yourselves, tell us a little bit about your background, your roles at your respective companies. To me, let's start with Geoff Greenfield, Director of Solar Strategy at Kokosing Solar. Geoff, I love your title. If you could tell us a bit more about your background in the industry and then what you do as a solar strategist for Kokosing.
Sure, Lucas. Thanks a lot. Thanks, Bob. So I've been in solar since 2000. So this will be my 25th year doing solar. And years ago, my wife and I started a smaller mom and pop business called Third Sun Solar. And we grew rapidly and had a lot of success and got larger and larger. And about 3 years ago, we were acquired by Kokosing Solar. And so I changed my title from president to director of solar strategy. And the focus there is making sure that all the people and all the industry knowledge that we had amassed over the years are adding to the success of our new larger team. I'm involved in business development, technology, evaluation, R&D, as well as project finance and helping with the feasibility studies, including the one that led to this project. Also note that Kokosing Solar is a member of the OMCO Solar Cooperative, very fantastic organization that we get a lot of benefit from. And I'm also a great believer in NABCEP. I sit on the board of directors of NABCEP, which is our industry's credentialing organization.
Excellent. Well, thanks, Geoff. We're really excited to chat and learn more about Kokosing. We're also joined by Eric Goodwin, VP of Business Development at OMCO Solar. Eric, how's it going? Could you tell us a little bit about your role at OMCO, your background in the industry?
Yeah, absolutely, Lucas. It's good to talk to everyone, Bob, Geoff as well. Geoff and I are not brothers, although we do kind of look alike. We have a similar hairstyle, work closely together. But I'm the VP of Business Development with OMCO Solar. We've got 6 manufacturing facilities across the nation. I'm based in our Phoenix facility, but our headquarters and where we built this project is outside of Cleveland, Ohio, and Wickliffe. I got my start in solar with a tracker startup company called Ray Tracker. About a year later, we were bought by the biggest solar company in the world at that time, or one of them still, in First Solar. And so I spent 5 years at First Solar, helping to develop the first solar version of that tracker. And during that time, OMCO Solar was a contract manufacturer at that point and supplied a lot of the structural components for our tracker and our fixed tilt. And that's how I got to know OMCO originally as a customer, if you will. And I transitioned, joined OMCO in 2017, right at the time that we decided to start bringing our own products to market. And we produce both fixed tilt racking solutions and single access trackers, anywhere from a half megawatt to 350 plus megawatt size projects. Again, all U.S. manufacturing. And we had the opportunity to work closely with Geoff and our customer, Kokosing, to support this project.
Great. Thanks, Eric.
Yep, definitely.
So with every Dispatches episode, we really try to focus on a single project and talk about how it came to be and the major players involved. In this case, we want to start out by learning a bit more about each company. So as I mentioned, Mayfield was the third-party engineering provider for this project. We did a lot of the electrical work on the permitting and construction plan sets. We relied heavily on Kokosing and OMCO for structural and construction support. So to get us started, I'd love to start by looking at kind of what OMCO is, what Kokosing is, and what you guys do, what markets you really focus on. So looking at OMCO first, Eric, in doing some research on OMCO, it looks like OMCO Solar as a company was founded in 2007, but the parent company, OMCO, has been around for 70 plus years. So if you could explain a bit about kind of what that relationship looks like, what is the parent company, OMCO, what do they do, and how do you work OMCO Solar with OMCO?
Yes, absolutely. So OMCO Holdings is our parent company, again, founded in the same building that we still are in Wickliffe, Ohio in 1955. So we have a big birthday this year as a company. It's 70 years old. We supply, out of the parent company, we supply roll-formed components for multiple industries. We've always had a very diverse industry base. We make about 95% of all the truck and trailer bumpers you see, 18-wheelers out on the highway. That comes primarily out of our Indiana facility. We also do a lot of material handling products. We do a bunch of other industrial roll-formed shapes. And the solar part of our division that was founded in 2007 came out of a vision from our CEO, Gary Schuster, who's still our CEO to this day, about being able to add value and seeing the growth in solar and renewables. And we started out from 2007 to 2017 as a contract manufacturer. I talked about the first solar relationship, and we made components for most of the players in the market. In 2017, we made the switch to start bringing our own products to market, and we've done now about 3.5 gigawatts of tracker and fixed tilt products. We've got 6 factories across the U.S. That makes us unique because we're, I believe, the only tracker supplier that makes every structural component in our own factory ourselves, including torque tubes, both in Indiana and both in Phoenix, Arizona. And we were just notified in the last 6 months from Wood Mackenzie that we're the market leader in supplying fixed tilt projects across the United States. I expect that data to be a little bit more detailed and published next year. They just now are starting to look at fixed tilt the same way that they look at the tracker market. But the picture that you see, that this is our Phoenix, Arizona plant, and between all of our factories, we've got right under 1 million square foot of manufacturing space, roughly about 13 gigawatts of annual capacity. So well positioned for growth, and it's been a great growth period over the last 6 years, especially.
Yeah, and I want to highlight a couple things you pointed out there, Eric. First one being, you've got 6 facilities across the U.S., right? You mentioned in Phoenix, as well as Ohio, a few other locations as well. Is that a strategic move? I know in some of our prep for this webinar, you've talked about, we specifically had sites in mind with supply chain really being one of the primary drivers for that. So if you could talk a bit about kind of where these facilities are and what the thought process was behind that.
Yeah, Lucas, that definitely was a big part of our decision. So in addition to the site in Ohio, our headquarters, and where we started solar is in the Phoenix, Arizona facility. We also have 2 facilities in Alabama, including a brand new facility that's been operational for almost a year in Huntsville, Alabama. We also have a facility in Talladega where we acquired in 2014, and we brought roll forming into that facility. And then our Indiana facility is in a city right close to Warsaw, Indiana, called Pierceton. And in addition to doing a lot of transportation work out of that facility, we have 2 torque tube lines where we roll tube. And then we also make foundations out of that factory. And so the strategic piece of it is to be able to have the shortest lead times possible. And we're extremely competitive in that respect. And then we always try to build as much of the product as possible, as closest to the project site. When you look at projects, freight is always a big variable. And using this project that we're talking about today as an example, we actually built the entire project out of Cleveland, put it down the 71, down towards the job site, roughly 2.5, maybe 3 hours tops for a commute. And that makes the supply chain a very easy part of the process.
Yeah, and I think that's one of the themes that's come out of really our discussions and prepping for this is locality was really a huge part of this project that we're going to talk about today, is bringing the local community together, whether it's the manufacturer like OMCO, developer like Kokosing, and even the utility itself, which we'll get into in just a bit. I do want to ask one more quick question for you, Eric. The IRA, at least as it stands today, who knows what's going to happen the rest of this year and beyond. The IRA does stipulate a few domestic content requirements for PV projects, one of them being that 100% of structural steel or iron must be US made. The other that 40 to 55% of manufactured components must be US made to get that 10% bonus adder. OMCO, it sounds to me like it will qualify as domestic content on most, if not all, projects in the US. Is that accurate? Do you have anything else to add to that, either on the steel and iron aspect or on the manufactured components aspect?
Yeah, Lucas, that is very accurate. We've always had the same business model from day one, which is US steel, US manufacturing. As a US steel company, I like to say, we're a steel company that buys tons of steel across multiple industries, but yet we're also a solar company because of our pedigree and our experience. And we're very well positioned for the IRA requirements. And that bill passing has really allowed us to provide a lot of value to our customers. Really, when you look at the fixed tilt product, it's looked at as 100% iron and steel, making the foundations and the racking. We qualify for that. Trackers looked at a little bit different as a manufactured product. And again, we're the only tracker supplier that makes all structural components ourselves in our own factories with US steel. We off the bat probably are one of the better positioned, if not the best, on domestic content. In addition to that, our controls come from the US. And what we've seen now is a rush to have an ability to have 100% domestic content tracker. And the only 2 areas where we don't meet that as of today are with dampers and our drive motors. And so we have a path and strategy to get to that option, whether if a customer uses a US module with safe harbor template, they might not need a 100% domestic content tracker, but we have the opportunity to offer either or. Kinematics is the largest supplier in the market of slew drives and motors, and their factory is literally 20 miles from us in Phoenix. So again, trying to simplify the supply chain. And I know there's a little bit of uncertainty right now in the market, just with all the things that are happening in Washington, but hopefully we'll continue to work through that. And but yeah, we're very well positioned in that respect.
I have a follow-up conversation point. Thanks, Eric, for that clarification. I would really like to loop in Geoff and even Lucas here too. From my vantage point, the IRA was a catalyst for domestic manufacturing. I presume we could all agree with that. But irrespective of the future of the IRA or in general, I'm kind of curious of everybody's perspective. How important is domestic manufacturing to the growth of the industry?
Yeah, I could take first stab at that. I think it's super important. I mean, there's been so much commitment including the new plant that we brought up in Huntsville. There's been so much invested in infrastructure, in power plants, in manufacturing facilities, and all the jobs that it creates. Again, I feel like we kind of have had an advantage because we never changed our model. But seeing what's happening and seeing the huge increase in reshoring in new manufacturing plants across the balance of systems, I think it's super critical and important. And I think it fits in really well with our new administration strategy of keeping things here and not building in China and other countries if we don't need to. So that's my 2 cents on that.
You want to add any, Geoff,
Sure.
from your perspective?
Yeah, I think, our memories are all fading, but we don't need to go back too far to remember the logistics crises related to COVID, where many of us in the solar EPC world were struggling with equipment being held up out at the ports or offshore, and it was there was already enough chaos back then. We didn't need more chaos, but so it was, I think, a reminder to many of us that thinking about our supply chains, thinking about logistics is just part of our role in getting these projects built. And so going with as local as possible obviously de-risks things. And then the second piece is I got into this business as an environmentalist, and I know that there's lots of very modern, clean facilities all over the world, but I would fathom to guess that buying things from a U.S. factory, we are aware of our regulations, we're aware of our working conditions, and so that helps me and many of my customers sleep better at night, knowing that it's not unsafe working conditions or environmental disasters overseas.
Thanks for your perspective, Geoff. I appreciate that.
I think one point to add, and it kind of segues into some of the news this week, when you look at things like the AI investment in the infrastructure and all the data centers that are being planned in states like Texas and other places across the country, we're going to need a whole bunch of energy to power that infrastructure. And I think that's another and there's also a lot of things happening within agrivoltaics around farms and other parts of our economy. But I think the AI piece is really interesting, as we're seeing a lot of data center influence on the solar energy.
Yeah, just on that point briefly, Eric, in the past 3 to 4 months, I talk about AI and data centers with different industry stakeholders, probably on a weekly basis. I'm sure, I don't want to give it away, but there's going to be a future dispatches on that topic. It's a big one for sure. Geoff, pivoting to you and Kokosing, really appreciate your passion and effort in this industry and all that you've done with NABCEP and Amicus. Can you talk a little bit about the maturation of Kokosing and the story? I know we've got the stats up on the slide, so to speak, but I'd be really curious to hear your perspective on it.
Yeah, sure. As I mentioned in the intro, we were acquired by Kokosing several years ago. We were growing and taking on, I think our largest project was up in the 4 megawatt range. And, as a smaller company with a smaller balance sheet, those big projects take up a lot of your working capital, and they also have to be bonded. And another great opportunity came in, great fit for our team, and we would have to get a bond. And because of our balance sheet, we could not get the bond. And so I had to turn away work that would have been part of our focus and our mission. And so it was, a great time to go out and look for capital. At the same time, Kokosing was looking for a solar company to roll into its own organization. So it was a culture fit and a values fit. And so now I've got the joy and pleasure of having a much larger team. In the picture there is the solar team from a all-team meeting that we had at our headquarters in Columbus. I think that was 2 years ago. And so we are a team within a larger organization. So Kokosing itself is an ENR Engineering News Record number 50 in the nation in terms of size and strength of large companies, building very large projects, wastewater treatment plants, factories, conventional power plants, combined cycle gas plants, very complex projects. And it was founded, I think, 74 years ago, and is privately held. And so it doesn't have to kind of blow with the winds of public sentiment. It can make decisions for long-term business and long-term business values, which was really important for us when we were looking for a partner. So now we have our same team, but it's larger, and then we get to call on the resources of larger Kokosing. So we're a self-performing EPC, which is great. We don't have to rely on subcontractors and scheduling conflicts and all the unknowns of that. And we also have a strong civil side of our team. A big part of Kokosing, folks here in the Midwest have probably seen our trucks on the sides of highways. We do a lot of heavy highway and bridge building, but we can tap into that expertise for larger ground mounts. Again, it's a great resource. Our footprint is the Midwest, so Ohio and the surrounding states, and then the Mid-Atlantic. So, Delaware, Maryland, Washington, D.C. areas. We just actually put solar on the rooftops of our offices down in the Mid-Atlantic. So it's great that the organization is walking their talk and doing solar initiatives on their own facilities. We've got about 4,000 team members, and so we can flex up for big projects and pull in carpenters and electricians and operators. And then when the project wraps up, they can move over to another project, which might be a large concrete or for a dam in Michigan. So it's a great resource. And then we've got our trained and focused solar specialists on the site leading the projects, doing QA, QC, and then in the offices doing the engineering, the development, the planning. There's a lot that goes into these projects, and we have a lot of partners. We've really relied a lot on OMCO in this case for this project. We'll talk more about that. And of course, Mayfield is one of our engineering partners that helps us when we get so much work that we need help. And we're excited about the market. It's already booming, and AI and the increased electrification of our inevitable move forwards is just creating that much more demand for clean energy.
Thanks for the context, Geoff. I really appreciate it. As a fellow strategist, I mean, we deal with our challenges, right? And we're talking about the challenges of this particular project. But what are you really excited about? Whether it's 10 years from now, this year, is there something that you're particularly focused on yourself or for the company that gets you excited?
Yeah, folks have been talking about storage for quite a while. We're actually starting to install it, which is really exciting. Storage is probably very popular in areas where there's a subsidy for it, or where the market conditions, are making it happen. But the changes in the PJM capacity auction are really driving the economics of storage at the same time that the global mass manufacturing of the key components in the supply chain is maturing to the point where the costs are getting to scale. So we're excited to pair a lot of these projects with storage, either retrofitting storage on existing projects or designing projects from the ground up with a storage component. And then as everything in the background, I've got a 53-watt module, which is what I installed on my house way back when, and then a typical 500, 600-watt module. That's just representative of the innovation and the continuous improvement that we're seeing in our ecosystem. And so better and better trackers, the algorithms that fine-tune the trackers, the design software that we all use to make these systems happen It's really exciting. And again, at the end of the day, we're trying to get as much solar into the grid as quickly as possible.
Yeah, we could have, I really appreciate that answer. Pretty excited about the value of resiliency. It is becoming better known with distributed generation and microgrid projects. It's great to see the impacts batteries are having on our industry. Let's step into the project, Lucas.
Yeah, I think we've alluded to this a few times by now, but let's actually like dig into it. And so, just to set us up a bit, this project took place in the city of Lebanon, just north of Cincinnati, Ohio. And the key challenge in this case was not only was the project owned and operated by a local municipal utility built on city-owned land, but it was built on a floodplain. And so that's going to be the main focus of our discussion for the rest of the webinar. But before we get into the specifics, I do want to start with you, Eric, about land procurement and kind of solar development more generally. As the industry matures, is it fair to say that a lot of these quote unquote perfect or ideal plots of land for PV are getting gobbled up, and we're having to turn as an industry to more sites like this one, where it's either unusable land or land that would otherwise be, suboptimal for a solar array?
Yeah, you are absolutely right. I think the exception seems to be these days when we do have sites that doesn't require a lot of consideration for either slope or grading or floodplains, as the site was. A lot of the larger sites, or a lot of the sites now that we're seeing developers go forward with. You're sometimes not paying as much for these type of sites as you would for larger sites, but our ability to work with our customers on getting a geotech, getting a topography report, understanding all the dynamics of a site, and then seeing what the best foundation solution is. I think this move to sites that are more challenged, I think is incorporated more ground screw foundations, helical. We have a ground screw option, of course, at OMCO, in addition to driven piles. So, and in some cases with landfills, ballast solutions. So I definitely agree with that.
Jeff, how did this project get started? And can you just give us a little bit of the taste? Obviously, politics are top of mind, but there's a lot of benefit to solar and distributed generation to a community. Can you explain, just give us an overview of this project?
Yeah, sure. Yes, jumping right in with the politics piece, there's red states and blue states and all that, but I really wish that solar was not politicized. If you think about it, making our own energy right in our backyard, independence, diversification, resilience, those are values that everybody in America can, nod their head and agree with. And on top of that, the economics are, something that we all believe in. Well, most of us believe in free markets. And so the mayor of Lebanon has been, a technologist and excited about solar since he was a kid, like many of us, and tracking the industry. And as a leader of the community, he has a responsibility to do right by his stakeholders. And they run their own municipal electric utility there. In Ohio, there's hundreds of smaller either cities or villages or regions that have their own utility, as opposed to the investor-owned utilities that serve the majority of the population. And so it's a opportunity for them to run their organization as efficiently as possible. They buy their energy, and they know that the rates are rising and there's volatility. They have to compete on the free market for extra power on super cold snaps like we're having right now. And so as a hedge against that volatility, having a portion of their energy being on site is something that they had explored. They looked at the numbers, and the numbers did not pay off. It just didn't pencil economically. It wouldn't be economically responsible. And they revisited that after the IRA law passed, and with the elective pay or direct pay provision that would allow them to tap directly into the investment tax credit piece, which changed everything. Their numbers got way better. And along with the cost of solar going down in terms of efficiencies, and the cost of conventional power going up. And so there's a crossover point that they suspected was there. They first ran an RFQ to do a feasibility study. We were awarded that small feasibility study component, and worked with them, generated all the assumptions, generated the designs, checked all the technical details, and came up with some options. They evaluated those and decided that it was economically attractive for their community to go solar. One of the pieces was they had land that they owned, called suboptimal land. It was in the floodplain, so it was not buildable for a school or public fire station. They couldn't sell it for commercial use or for private home developments. So it was a great use for that land. They decided to go solar. We moved forwards with it. And we'll talk later about the projects and how we address some of the technical challenges. But yeah, it was very refreshing to have decision makers looking out for their citizens, looking out for what's the best economics, and not being so polarized based on just the fact that somebody at the other party had thought it was a good idea years ago. These decision makers weren't going to let that color their vision, and they looked at things with a fair, clear eyes and decided that this was a great opportunity to improve their community.
Thanks for that thorough background, Geoff. Just kind of a follow-up question, and part of the reason that we put dispatches together. It is a complex industry, right? Because you got hardware, software, design, build, a lot of communities. How important is it for you working with an OMCO, working with a Mayfield, in particular to get these more complex projects built?
Yeah, in some ways, as a director of solar strategy, maybe my job should be to say, steer away from complexity and focus on simplicity and lower risk projects. I think there's a little bit of scrappiness for folks in Ohio and some of the other states that aren't blessed with, high energy costs and perfect solar sites and state subsidies. We've always had to be scrappy to make projects pencil here. And so we're kind of by nature willing to look at a project that might be a challenge. And then Kokosing as a whole kind of prides itself on taking challenging, complex projects that many organizations couldn't take on. So it's a good fit for the parent company as well. And then over the years, our team in-house, as well as our network of partners, we're not working with folks that are new to the industry. We're working with folks that are focused on tried and true methods, as well as a cautious approach to new methods. None of us want to beta test things on our clients. We don't want bleeding edge. We want kind of maybe close to cutting edge. Maybe not state of the art, but maybe state of the shelf, something that's been up and running and proven for a couple of years. So OMCO and Mayfield share that ideology. They're creative and problem solvers, but also are going to be good partners and say firmly, hey, I don't think this is a good idea, or the way that you're talking about doing that looks like it could have problems, and here's what we think the problems could be. So a lot of collaboration. It's been a great partnership.
That's great to hear, and probably an excellent segue into our next slide. Lucas, I think that this project had a lot of engineering and design considerations around the floodplain. Why don't you take it away here?
Yeah, thanks, Robert. So what we're looking at here was supplied by OMCO. So thank you, Eric. Thank you, Michael, on the call, also from OMCO for providing this data. As you can see, this is 3 arrays. So this is kind of an aerial of what was planned out for the project. 3 distinct arrays, western, central, and eastern sites, located in a floodplain. And so that being one of the primary engineering challenges here, that's where we do want to focus our attention for a bit. Even before that, I want to take a step back and open it up to Eric, Geoff, even Robert. Can we define for the audience what a floodplain is and why that may impact our engineering choices here?
On the floodplain piece, and I'll let Geoff and Robert add as needed. When we look at it from an engineering standpoint, if you've got an area that has a history of flooding, and you've got elevation concerns, and in this case, I think Geoff had mentioned that it really wasn't another purpose for this site. But normally when we see areas that are identified as floodplains, we know that we need to work closely with the customer to figure out what a minimum above floodplain is. So the base flood elevation that's showing on this chart is kind of what we use as a baseline, and we collaborated with the customer on a minimum 2.5 inch or 2.5 foot front edge and a 6 foot from the floodplain. So it's just about the topography and how the geotechs are done and how the land is identified. And a lot of times it's based off a history of floods or the potential of these events happening.
Yeah, not much to add there. Any site has its own ministerial, permits, and part of the diligence is addressing wetlands as well as potential floodplain elevations, et cetera. And so floodplain can mean lots of different things. Some folks might be focused on a 50-year or a 100-year or even a 500-year floodplain. I believe in this location, it was the 100-year floodplain that we used. And the design, was basically, hey, we've got to keep the electronics, the modules and the wiring and the inverters out of the water. We're confident that the galvanized steel piles, should there be a flood in this area, the rising water will be fine. It's just designing around it. We'll talk a little bit more of the complexities.
We actually have an interesting question, and partially ties into my background, former in banking. So Lindsay Gunther, Director of Environmental Affairs from Lightsource BP. What design approaches did you take to mitigate the flood risk? How did you get insurers comfortable with the project entirely in a floodplain? Was the city willing to take a higher PPA rate to account for higher insurance costs? I know we're talking about a couple of things here, but something that I've been particularly paying attention to are these challenges, right? They're real challenges from an insurance and lending perspective. Eric, can you talk a little bit about some of those issues, how they were addressed? Or
yeah, I'll jump right in. They mentioned PPA. I think one of the good things here is we had a municipal customer that's going to be an owner, a simple owner of this project. So they didn't have to answer to a debt lender, and they didn't have to satisfy insurance providers other than their own. To be honest, I do not know if they had any change in their insurance rates or what kind of underwriting the insurance that they have took for this. Obviously, like all the other city-owned facilities and assets, it's insured. And perhaps because it's part of a pool of other assets, the risk might have been diluted, in dollar value. I think that the biggest concern is, will the system survive and continue to be operating and be safe in any kind of weather condition or rising water condition? And that's the standard that we drove, that we designed around. And then all the other normal, structural design standards, primarily wind applied here. And so, I think that there's probably some floodplains that are wet year round where they might be soupy soil that the soil itself might not stand up to the geotechnical analysis or the pole tests. So I don't want to create any kind of sense that all floodplains are buildable or your floodplain might be a great site for solar. I think there's an investigation, and these things can really vary. This is a relatively dry area where it wasn't annual or seasonal flooding. It was the potential for, once in 100-year floods. Although we've had once in 100-year floods, every 2 years in some other parts of our state. So I think as weather evolves, that's going to be a bigger concern. So yeah, definitely a factor. I would say that, debt is priced based on risk, and a lot of equity investors are pricing in risk. And so if they can, get comfortable with that risk and understand from the engineering piece how that risk is addressed or offset, hopefully they'll get comfortable with it.
Great. Well, thank you again to Lindsay and really everyone submitting questions. As a reminder, we do have the Q&A tab here in Zoom. So if you would like to submit more questions, we will. All our panelists have that window open and we'll be more than happy to answer your questions. So please keep submitting them. On that note, we did get one just now from Patrick Fleming. Maybe this is one for you, Geoff. If you could just run us through really quickly project timeline, just zooming out from due diligence through permitting, design, site prep, construction. Roughly how long does this whole process take?
Yeah, sure. I'm going to be shooting from the hip here. So I'll speak in rough numbers. Typically, the due diligence piece was what we covered under the feasibility analysis. We did a lot of engineering. We didn't have to go through a utility interconnection queue because of the municipal utility. We're connecting to their own private, or I guess publicly owned, municipally owned grid. So that was actually one of the nice things about working with the municipality. In fact, they got their own line workers and capacity to install. So our point of common coupling, we ran our system output just right onto the edge of the system, and then they took care of the medium voltage collection lines as well as part of their side of the project. So diligence in general, pre-construction, permits, design, typically takes 4 to 6 months. I think we're a little bit on the shorter side here. Long lead time items, oftentimes transformers or high voltage switchgear are oftentimes the critical path for long lead time. Those were ordered early enough so that they arrived and everything, was on site by the time we needed it. And so then we focused on the seasonality of what time of year to build, and got this thing, I think, pounded out. The piling took about a month and a half, and racking was chasing them. And so I think the mechanical installation took just over 3 months, and electrical was following them. So I think the actual construction piece on this project was, under a half a year.
Great, and I really want to focus in on that construction process here for a bit, and I'll turn it to you for this, Eric. So we've got, again, a visual on screen here showing the 3 distinct arrays. We're calling out here a base flood elevation, and then also a clearance above that. I'm going to move us forward. We have one additional visual here. So again, we're looking at one of those 3 arrays in the bottom left and some pile heights in the upper right. So Eric, if you could take it from here, kind of walk us through what we're looking at, what these different elevations mean, and how that could relate to project construction.
Yes, definitely. In looking at the previous slide, we had individual layouts for each of those 3 arrays. And so what we did for each of those is we identified within that CAD layout pile points And then we use that base flood elevation, and then obviously with the guidance of at least the 2.5 foot front edge. And we were able to take those measurements and kind of back them from the base flood elevations to come to a different pile height, or the pile heights that were needed. And so what you see on the screen is the longest one being the teal, where, as a custom row former manufacturing all of our own products, we can adjust and design to wind, snow, loads, floodplains. And so what we did is we identified on the CAD blocks each of these pile points, identified, and you can see on the lower screen, where we kind of put together in the color coding of the whole layout. And then we work through a preliminary set and through a final CAD, walking through with Kokosing on approvals. And then I think just as an important part, before we shipped, we went through very detailed in our packaging and our labeling with the construction teams on what was arriving, in what array, and how to best go about it. But we basically were able to take those base flood lines, and I know enough to be dangerous on this, and definitely this project, but we have a very talented engineering team, mostly based in Phoenix, and Andrew Guerrero specifically, that did some great work on putting this together. But that's kind of the overview and the approach that we took. And again, we ended up with the 4 different pile lengths.
And Eric, it sounds like this is the typical approach that you would take for a site with such a varying topography and different grades that you'd be working throughout the array. Is that accurate, that this kind of color coding system is something that you guys tend to rely on difficult sites?
Yeah, it is. This is definitely an extreme case, one of the more extreme cases. But we try to look at the topography, and for fixed tilt sites, we're really focusing on pile length and pile reveal heights of what you're going to need. And then in some cases, we might only be constrained by a pile driver. We normally, in our data sheets, look at a 20% slope. We have the ability sometimes to go higher on a fixed tilt product. On a tracker site, in addition to using reveal heights for depressions and for slope, we also have a design feature in our torque tube that has some flex to it as well, to handle slope. But this is the general approach our engineering takes. And I have to say, when you have really good data and good layouts, which I have to give the Kokosing team and Lucas, your team, I'm sure as well, with the engineering that was done, it really makes it a lot easier to put this together. Because I think one of the challenges is that sometimes you don't get all the information. You're trying to piece something together, and this was really helpful for us to have all the original layouts in the form they were, and all the information to work with. Made it a lot easier.
Great, and I'm really curious. This might be a question for you, Eric. Maybe you, Geoff. We're looking mostly at racking here. What about other balance of system components? So presumably we're in a floodplain here. We need to be above a certain elevation for the array itself. Does that also apply to things like combiner boxes or inverters that are naturally going to be a part of the system, other electronics that we're installing? Are we also installing those above a certain base elevation? And what does that structure look like?
Yeah, absolutely. Obviously, electricity and water is a touchy subject, and these are long-term assets that we want to keep on working at peak performance. So the inverters, combiner boxes, any kind of power electronics were located also along with the modules themselves above the floodplain top line. And so that's one of the reasons why we did this. We've also got a different project in another location for a different customer, where we installed a battery energy storage system that was also in a floodplain. And so it was a simple matter of fabbing some steel support structure for the BESS. Most BESSes go on a slab on grade. In this case, we just had to do the structural work and fab a steel structure to hold have some stairs and have a work and access area platform and then set the BESS on top of that, which BESSes are pretty heavy, so it's some heavier gauge steel, but we had no trouble with that. So that's another opportunity to consider, creative solutions where somebody else might say no. The scrappy EPC and developer might say, hey, this is an opportunity for us to serve the client, solve a problem, differentiate ourselves in the marketplace. This color coding piece, I will say, it's hard to see unless you zoom in on the slide, but this is just one of the 3 subarrays where we had a very detailed pile by pile color coding scheme. So when we laid these things out, it did go a little bit slower. We had to be more cautious about laying out and tagging by color which piles go in which locations. And then we distributed the piles out there so that when we came by with the driver, we picked up the pile and we knew it was the right length for that spot. So pre-planning, coordination with the supplier, they worked with us on this, and everyone was on the same page with logistics. And then we had, one team acting together to make sure that this thing went in. If you got the wrong pile in the wrong spot, that's part of the ways that projects get sideways, and they cost money. Any mistake costs a lot of money. So investing ahead of time in the pre-planning, our administration and operations team did a lot of this. And then we went out there, received the piles, they were marked, they were color-coded. We distributed them carefully. And then after that, the pile driving went, as a normal site would. We'll see another picture later. The actual mechanical construction was also a little bit slower, working, well above grade for the deepest area of the site. So we had to plan for that and make our best estimates as to what the production factors were going to be for that operation. And, came in ahead of that, which is hopefully where you want to be. You don't want to be too far ahead. You don't want to be upside down, but you want to be as close to your estimate as possible. And we did some good prep work and came in with a good estimate.
I think this is a great slide, right? Because you see why the project gets built in the first place. And I think it's pretty meaningful. Geoff, I'm kind of curious, as a project developer, seeing a lot of systems go up, how do you see the communities react after these things go online?
Yeah, well, that's becoming a larger as solar, grows in popularity. It's one thing to put solar in the middle of nowhere, out of sight, out of mind. But especially here in the Midwest, we're a relatively heavily populated state with a lot of agricultural land, but there's houses and the suburbs are growing. So some of the larger solar projects have become controversial, unfortunately, with folks, many of them with genuine, appropriate concerns about their property value, or about noise or about safety. And a lot of the good developers, take those concerns head on and try to educate the public, involve people in planning, really talk about appropriate screening and fencing, et cetera. This project is small enough that it wasn't really targeted for an anti-solar backlash. Some of those are manufactured kind of astroturf movements. And again, I think because the local leadership was effective on their engagement with the public, they talked about the benefits. They talked about the careful evaluation of why. They talked about the economic drivers, including making the community an attractive place for businesses to relocate, and the growing desire for many companies to power their operations with either 100% or a portion of their power being clean and local. So I think the community got behind this. There's already trust there. And so it was treated as a point of pride for the community, as something forward thinking, but also economically conservative.
It's great. Thanks for the thorough feedback. I just, from my perspective, particularly with Outfit, telling these stories and showing the impact, I think it's something that both OMCO and Kokosing Mayfield as well do a really good job of. You got to get these stories out there. Quick question from Troy Spraker here. With these projects being constructed in the floodplain, can you describe the floodplain permitting process? And if there were any no-rise certifications or modeling?
I didn't hear the last part of that question. Any what kind of?
No-rise certifications or modeling. If you had the model, how did you model the impacts to the floodplain?
Gotcha. I think I understand that question. So in many areas where there's a river or a water feature, one of the design criteria is making sure that water can flow through the area if there is one of those 100-year floods. And so building in the floodplain, even if you built maybe a raised concrete pad to build buildings on top, you would be displacing the water flow rates. So that was evaluated in the permitting process, and the piles themselves were determined to not be a threat to slow down the flow through of water, which again, effectively, if you create a dam and something, you might raise the water upstream from you, which would be something that the evaluators, the HJs, et cetera, are and should be concerned about. So, so that was considered. And let's see, as far as software, there wasn't anything specific that we had to do, because once we had the determination that these piles were not going to create an obstruction. So I don't know the answers. I'm sure there are software solutions out there for quantifying exactly what kind of an impact a different kind of structure would have on the free flow of water during a flood event.
We've had a very active audience today, and we have more questions that we can answer in this hour. Here's the results as we kind of wind down the episode. We only have a few minutes, Geoff, but how do both of you guys feel about this project?
I'll start before Eric. It's a point of pride for us to have a project in our backyard with a happy customer that's already benefiting from this right now. Energy. They started this project before the PJM rate shock sent headlines through the industry, and so it was good economics before, when we were using somewhat conservative projections of utility inflation, and then everybody kind of like nodded and patted themselves on the back and said, well, how about that? When the rate shock announcements came through, this percentage of the utilities baseload is not subject to energy volatility. So the economics just got better after that. So customers happy, the community's happy, and then we're happy to have a project right in our backyard. We drive through this area all the time. My wife's from Cincinnati. My parents, announced their engagement in Lebanon, Ohio. So it's got some connection to my family here. Eric, how about you?
Yeah, you covered a lot of awesome points that I would agree in, especially, I think for us, it's it's satisfying to be able to do a project and have the collaboration that we had with your team, and also be able to handle some of the challenges that came with this project. So, but the other piece is just there's an all Ohio connection here. Again, OMCO as a company stands for the Ohio Molding Company. Just a little trivia there. And so we really are proud of being able to do more work in the state. And in this day of all the uncertainty that we're all kind of navigating and figuring out with a new administration, these are the type of stories that we need to get out there. And I think we have a bullet point on crossing political boundaries. There's value out of this project to the community and getting power and hitting a cost point. And it is one of the funner things that we've had an opportunity to do. So we're very excited to be a part of it, and it's in our backyard too. So
Well, I appreciate both of you taking part today.
thank you.
We have everybody's contact information here. It's a pretty busy episode. We do have a surprise for February that's not fully ready to unveil yet, other than I'll say that we're going to have a live dispatches the night before Inter Solar in San Diego, which should be fun, as well as a regular episode in February too, that I think Lucas might be able to talk a little bit about soon. But yeah, it's been really busy. Lucas, do you have anything else you want to add to today's episode?
Just want to thank everyone again for their time. Eric, Geoff, thank you so much for sharing this story. And one final reminder for folks that we will share the recording, we'll share contact information, all that good stuff afterwards. So keep an eye on your inbox and you can find more information.
If you have any complex consulting engineering questions, send them to Lucas's email at Mayfield. He's happy to help you out.
Well, thanks everybody. It's been a pleasure.
Thank you
Thank
guys.
you.
Appreciate it.
Thanks, everyone.
Bye-bye.